Okay, so in the last video we left off finding the sum from 1 to 100. So if you think of all 100 integers, okay, so there's 100 of them, and what we did is we paired up the first and the last, so 1 plus 100 to get 101, and then the second to last, and the third to the third to last, all the way till we got to the 50th and 51st numbers and added those together. So since, oops, I forgot a zero there. Since there are 100 numbers, and we're pairing each of them up, that's really like 101 50 times. So if we do 101 times 50, we end up getting the sum, which is 550, which represents the sum of the first 100 integers. Okay, now there's a formula to do that, and it's this right here. So you should know the nth term formula, and you should know the sum of an arithmetic sequence formula. Alright, so this is only for sums of arithmetic sequences. And a quick proof of it has to do with the example we just did. So let's say I have the first n integers. I can express it like this. Then if I write the sum again, but I write it backwards like this, alright, these are arithmetic, which means there's a common difference from one term to the next. So if I add these rows together, you get 2 times the sum is equal to the first term plus the last term, and then the second term to the second to last term. But these sums are equal to each other because we just showed it, right? We talked about the difference from the first term to the second term is the same as from the last term to the second to last term. So just like 1 plus 101 is equal to 2 plus 99, alright, all of these sums are going to equal each other. And there's n of them because we got, you're grouping these together, it's twice the sum, so 1, 2, all the way to n terms. So if we take this formula down here and just divide both sides by 2 to get the sum, we get the sum is equal to the first term plus the last term times n over 2. Alright, and that's the formula right there. So yes, you can use a calculator. I showed you in the last video how to do that, but this is like another way to find the sum, and it'll help you with certain word problems. So you should know how to do it this way. So we could come up with a formula for just the sum of the first integers from 1 to n. So using the formula, remember it's the first term plus the last term times n, so if it's 1 to n, there's n terms, divided by 2. So that formula would be n squared over 2 plus 1/2, if you want to write it that way. So if I wanted to know, alright, what's the sum of the first 10 digits? So like, what's the sum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Add them all up. Well, it would be 10 squared over 2 plus 1/2. And that would, oh, this is not a, sorry, typo. This is not a 1/2, that's an n. N over 2. Alright, so when I substitute, that should be 10. So we get 10 squared divided by 2 is 50, plus 5. Okay, and we get 55. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 is equal to 55. And if you wanted to do like the first 50 terms, well then you could just use this formula and plug in 50 for n. Okay? Let's do one more for this video. So now the partial sum. So those are for infinite sequences that go on forever. Partial sum just means you want to add the first couple terms. So use a calculator to find the 150th partial sum of this arithmetic sequence. Now we could use summation notation, or we can also use these formulas. So first I'm going to come up with the nth term formula here. So that would be the first term, oops, sorry, that would be the, so I'll make a new calculator here. So I'm going to do a sub n colon equals the common difference, which from 5 to 16 seems to be 11, times n minus 1 plus the first term. So if we want the first 150 terms, we need to find the 150th term, which is 1664. Alright, so now to use the formula, we're going to do the first term, which is 5, plus the last term, which is 1644, divided by 2 times the number of terms, which is n, which in this case is 150, since we're doing the first 150 terms. Alright, you could also do summation notation and do, alright, from the first term to the 150th terms, and then put the nth term formula here, which we already defined, so we don't have to type this part in again, and we get the same answer. So you should know how to do this both ways, but that's just some calculator work there.